If you can recall back in your study of Calc 1, we were talking about related rates, and if you can recall, we had things changing with respect to time, and a lot of times we had three variables in our problem because time was a factor. Well, we're now going to be doing something similar to that, dealing with the motion of an object, where we're going to, again, introduce time. We're going to be studying something that's called parametric equations. At the end of this lesson, you'll be able to describe what a parametric equation is and how to eliminate something that's called the parameter. All right, consider the path followed by an object that is propelled into the air at an angle of 45 degrees. If the initial velocity of the object is 48 feet per second, the object travels a parabolic path given by y equals negative x squared plus x squared over 72 plus x. And it's going to look something like this, obviously. It goes up into the air at a 45-degree angle, and then eventually it's going to come back down. Okay, so the equation doesn't tell the whole story. It tells you where the object has been, but it doesn't tell you when the object was at a given point. Right? So it doesn't tell you after 2 seconds where is it at, after 3 seconds where is it at, exactly. So to determine this time, you can introduce a third variable t called a parameter. All right? By writing both x and y as functions of t, you can obtain the parametric equations. So you'll notice we have x equals 24 square root of 2t, and y equals negative 16t squared plus 24 square root of 2t actually describes the x and the y values at a certain spot in time. So x would be where is the object at horizontally, and y would be where is that object at vertically. Right? So when this asks where is the object at t equals 0, we would just plug in 0 in for our t's into this equation. We'd get x equals 0, and we would actually get y equals 0. So at time equals 0, we are at the point 0, 0, and if I were to actually put this on an xy axis, that's exactly where we're at. And then if I'd want to know where we're at time equals 1, we could plug 1 in there. We're going to get x equals 24 square root 2, and y is equal to, if I plugged 1 in there, I'd get negative 16 plus 24 square root 2. So the point that this would be at would be 24 square root 2, negative 16 plus 24 square root 2. And if I got out my calculator, I actually could figure out what is going on there. I'm guessing it's going to be, somewhere around here, something like that. It might even be up here a little bit. So it's just telling where is my object at a certain amount of time. So it's almost tracking something as it's moving across space. Right, a parametric equation then, if f and g are continuous functions of t on an interval I, then the equations x equals f of t and y equals g of t are called parametric equations, and t is called the parameter. So it's just we're separating the function into its x component and its y opponent. And when we're finding a rectangular equation that represents the graph of a set of parametric equations, it's called eliminating the parameter. Okay, so we will mostly on this one, we will have a set of parametric equations, and we'll be able to graph them, and then we'll also be able to eliminate the parameter so we can figure out what function did we start with if that didn't have a t in it. Right, when we eliminate the parameter, there are two things that we're going to do. The first one is that we're going to actually solve one of the equations for t. I usually like to solve the x equals equation for t. Not necessary, but that's usually what I like to do. And then we're going to plug t into the other equation, and then we will solve. All right, so what you'll notice in my next video is we're actually going to graph parametric equations, and then we will be coming into a rectangular equation by eliminating the parameter. So hopefully now at least you're familiar with what a parametric equation is.